Jupiter, a giant among giants. This colossal gas planet reigns supreme in our solar system. It's surrounded by a bustling family of over 90 moons. Today we journey to one such moon, a tiny world named Aoede. Aoede is a moon dwarfed by its massive parent planet. Despite its diminutive size, Aoede holds a special allure. It's a celestial puzzle, with many secrets waiting to be revealed. Join us as we embark on a cosmic adventure to understand this tiny world in a giant's shadow. The story of Aoede's discovery is a testament to the power of modern astronomy. In the vast expanse of space, finding a small, faint moon orbiting a distant planet is no easy feat. It was the year 2003, and a team of astronomers led by Scott S. Shepard was using the powerful Subaru telescope in Hawaii. Their target, the Jovian system. And there it was, a faint point of light moving against the backdrop of distant stars, a telltale sign of a moon orbiting Jupiter. This new moon, later designated as Aoede, sparked excitement and curiosity among astronomers worldwide. It was a reminder that our cosmic neighborhood still holds secrets, waiting to be discovered. Aoede, like many of Jupiter's outer moons, is a small and faint object. Its estimated diameter is a mere 4 kilometers. Its small size makes it incredibly faint, reflecting very little sunlight back to us. Despite its diminutive size, Aoede is still gravitationally bound to Jupiter, orbiting the giant planet in a vast elliptical path. Understanding the size and mass of objects like Aoede is crucial for astronomers. It helps us comprehend the dynamics of the Jovian system and how these moons formed. Peering at Aoede from Earth, even with our most powerful telescopes, reveals little about its surface. However, based on what we know about other small outer moons of Jupiter, we can make some educated guesses. It's highly likely that Aoede's surface is heavily cratered, a testament to billions of years of impacts from asteroids, comets, and other space debris. The surface is likely very dark, reflecting very little sunlight. Until we have detailed images, we rely on what we know about similar objects to paint a picture of this distant, cratered world. While direct observation of Aoede's surface remains a challenge, astronomers can infer some clues about its composition by studying its light signature. By analyzing the way light reflects off Aoede, we can learn about the materials that make up its surface. These observations suggest that Aoede, like many of Jupiter's outer moons, is likely composed primarily of rock and ice. The exact proportions of rock and ice are still unknown, but it's likely that Aoede's internal structure is relatively homogeneous. Further analysis could reveal the presence of other materials, such as organic molecules. Aoede is a member of the Pasiphae group, a collection of irregular moons that orbit Jupiter in a retrograde direction. This unusual orbital characteristic suggests that Aoede and its fellow Pasiphae moons were likely captured by Jupiter's gravity long ago. Aoede's orbit is also highly eccentric, resulting in significant variations in its distance from Jupiter. This distant and eccentric orbit means that Aoede is subject to weaker gravitational forces from Jupiter compared to the planet's inner moons. It's likely that Aoede is geologically inactive, a cold and quiet world shaped primarily by impacts. Studying a tiny, faint moon like Aoede, located millions of kilometers away, presents significant challenges for astronomers. Aoede's small size means it reflects very little sunlight, making it incredibly faint even against the darkness of space. Furthermore, its distance from Earth and its proximity to the much brighter Jupiter further complicate observations. Despite these challenges, astronomers have devised ingenious methods to extract information from the faint whispers of light that reach us from Aoede. One of the primary tools astronomers use to study distant objects like Aoede is spectroscopy. This technique involves splitting the light reflected from an object into its component wavelengths. By analyzing the specific wavelengths of light absorbed or reflected by Aoede, astronomers can infer information about its surface composition. Spectroscopic studies of Aoede suggest that its surface is likely composed primarily of water ice and rocky materials. These studies can also reveal clues about the presence of other compounds on Aoede's surface, such as organic molecules. While direct observations of Aoede are limited, astronomers can leverage theoretical models and computer simulations to bridge the gap in our understanding. These models incorporate what we know about physics, gravity, and the formation of planetary systems to make predictions about Aoede's unseen characteristics. For instance, by modeling the gravitational interactions between Jupiter and its moons, astronomers can estimate the tidal forces acting on Aoede. However, due to Aoede's small size and distant orbit, these tidal forces are likely weak, suggesting that it's a geologically inactive world. Further observations of Aoede are crucial to refine these models and paint a more accurate picture of this distant moon. The study of Aoede and other small outer moons of Jupiter is a testament to the insatiable human desire to explore the unknown. Future missions to the outer solar system, equipped with more advanced telescopes and instruments, hold the promise of revolutionizing our understanding of these enigmatic objects. Missions like NASA's Europa Clipper could provide valuable flyby observations of Aoede and its neighboring moons. These flybys could capture higher resolution images of Aoede's surface and conduct more detailed spectroscopic studies. Ultimately, a dedicated mission to the outer Jovian moons would provide the most comprehensive study of these distant worlds. In the vast cosmic ballet of our solar system, each celestial object moves to a specific rhythm, dictated by the laws of gravity. Aoede, despite its small size, is no exception. This tiny moon is locked in a perpetual dance around its massive parent Jupiter, following a path shaped by gravitational forces. Aoede takes approximately 758 Earth days to complete one full orbit around Jupiter. Aoede shares its orbital neighborhood with a group of other irregular moons known as the Pasiphae group, all moving in a retrograde direction. Most of the moons in our solar system orbit their parent planets in the same direction as the planet's rotation. However, Aoede and its fellow members of the Pasiphae group orbit Jupiter in the opposite direction, a phenomenon known as retrograde motion. Retrograde orbits are strong indicators that a moon didn't form in its current location, but was captured by the planet's gravity. The most likely scenario for Aoede and its retrograde companions is that they were once independent objects, perhaps asteroids or comets. As they ventured too close to Jupiter's gravitational domain, they were ensnared, their paths forever altered. Unlike the nearly circular orbits of planets like Earth, Aoede's journey around Jupiter is far from perfectly round. Instead, it follows a highly eccentric path, an elongated ellipse that takes it closer to Jupiter at some points and farther away at others. Imagine a comet streaking around the Sun, its tail trailing behind as it swoops close to the Sun and then swings back out to the distant reaches of the solar system. While not as extreme as a comet's orbit, Aoede's path shares this elongated characteristic. This eccentricity means that Aoede's distance from Jupiter varies significantly throughout its orbit. At its closest point, known as perigove, Aoede is approximately 22 million kilometers from Jupiter. However, at its farthest point, or apogee, it's over 24 million kilometers away. This constant change in distance has implications for the forces acting on Aoede. When closer to Jupiter, the giant planet's gravitational pull is stronger, like a cosmic tug pulling Aoede closer. As it moves farther away, the gravitational influence weakens, allowing Aoede to stretch its orbital path outward. Despite the chaotic nature of its capture and its eccentric orbit, Aoede's motion is not entirely random. It exhibits a phenomenon known as orbital resonance, a subtle dance between a moon's orbital period and the orbital periods of other moons in the system. Imagine pushing a child on a swing. If you time your pushes just right, matching the swing's natural rhythm, you can make the swing go higher and higher. Orbital resonance is similar. When two celestial objects have orbital periods that are simple ratios of each other, their gravitational interactions can create a stable repeating pattern. In Aoede's case, it's in a 3-to-5 resonance with another moon in the Pasiphae group named Caliro. This means that for every 3 orbits Aoede completes, Caliro completes 5. This resonance helps to stabilize Aoede's orbit over long periods, preventing it from being perturbed into a different path by the gravitational influence of other moons, or even by Jupiter's own non-uniform gravitational field. While Aoede's orbital dance may seem chaotic at first glance, it's a testament to the delicate balance of forces that govern our solar system. It's a dance of capture, eccentricity, and resonance, a cosmic ballet performed on a grand stage, millions of kilometers from our own planet. Jupiter, the king of our solar system, reigns over a vast family of moons. With over 90 confirmed satellites, it's a bustling celestial neighborhood. The most famous are the 4 Galilean satellites, Io, Europa, Ganymede, and Callisto. Discovered by Galileo in the 17th century, these massive moons are worlds unto themselves. Io is a volcanic inferno. Europa harbors a vast ocean beneath its icy surface. Ganymede is the largest moon in our solar system. Callisto is heavily cratered and ancient. Beyond these giants lie a myriad of smaller moons. There are moons shaped like potatoes and moons with rings. Some moons were only discovered recently with powerful telescopes. These moons can be categorized by size, orbit, and origin. Aoede, with its retrograde orbit, is an irregular moon. These moons are remnants of a chaotic past, captured by Jupiter's gravity. To understand what makes Aoede unique, it's helpful to contrast it with its larger, more well-known siblings, the Galilean moons. These celestial giants showcase incredible diversity within a single planetary system. Io is consumed by volcanic activity. Hundreds of volcanoes spew molten lava and sulfur dioxide. Tidal forces from Jupiter generate immense heat. Europa is an icy enigma. Its surface hints at a dynamic interior. Scientists believe a vast ocean lies beneath. Ganymede is a world of contrasts. It has a metallic core and diverse terrain. Ganymede has its own magnetic field. Callisto is a heavily cratered relic. Its surface records billions of years of impacts. Callisto shows little geological activity. These giants contrast with the small, quiet Aoede. Aoede's evolution is driven by impacts and time. Section 3. Echoes of the Past. Similarities with Irregular Moons. While Aoede may pale in comparison to the grandeur of the Galilean moons, it shares a kinship with a vast population of smaller, irregular satellites that swarm around Jupiter. These moons, often overlooked, hold valuable clues to the early solar system and the processes that shaped planetary systems. Like Aoede, most irregular moons are thought to be captured objects, remnants of asteroids, comets, or even larger planetesimals that ventured too close to Jupiter's gravitational grasp. Their captured origins are evident in their often eccentric orbits, their varied inclinations, and their tendency to orbit in the opposite direction of Jupiter's rotation. These irregular moons are like celestial fingerprints, preserving evidence of the chaotic conditions that prevailed during the early solar system's formation. By studying their orbits, compositions, and surface properties, astronomers can piece together a picture of the events that led to their capture and the evolution of Jupiter's moon system as a whole. Aoede, as a member of this diverse group, provides a unique window into this ancient past. Its small size and distant orbit suggest that it has remained relatively unchanged since its capture, preserving a record of the early solar system's composition and dynamics. Section 4. The significance of being small. Understanding the role of irregular moons. In the grand scheme of our solar system, small irregular moons like Aoede might seem insignificant. They lack the grandeur of the giant planets, the volcanic fury of Io, or the potential habitability of Europa. However, these diminutive objects play a crucial role in our understanding of planetary system formation and evolution. Irregular moons, with their captured origins and diverse orbits, provide a glimpse into the chaotic early days of our solar system. Their presence around Jupiter and other giant planets suggests that capture was a common process in the early solar system, shaping the architecture of planetary systems and influencing the evolution of larger moons. Furthermore, the study of irregular moons can provide insights into the composition and distribution of objects in the early solar system. By analyzing their surface properties and compositions, astronomers can learn about the building blocks from which planets and moons formed and the processes that led to their diverse chemical makeups. While missions to the outer solar system often focus on the larger, more alluring targets like Europa or Titan, the study of irregular moons like Aoede should not be overlooked. These small worlds, with their stories of capture, chaos, and resilience, hold valuable clues to our solar system's past and the processes that shape the planetary neighborhood we call home. Section 1. A Universe of Tiny Wonders. Our journey to Aoede has taken us millions of kilometers from Earth, to a realm of giant planets and their enigmatic companions. We've explored Aoede's diminutive size, its ancient cratered surface, and its place among the Jovian moons. What have we learned from this tiny world in a giant's shadow? Even the smallest objects in our solar system can hold profound secrets. Aoede provides a glimpse into the chaotic early days of our solar system. Imagine holding a tiny grain of sand in your hand. Under a microscope, that grain of sand reveals intricate patterns and a story of geological processes. Aoede is like that grain of sand, revealing a fascinating history. Aoede is not alone in its diminutive stature. Our solar system is teeming with small moons, asteroids, and comets, each with a story to tell. These objects hold valuable clues to the formation and evolution of planetary systems. Section 2. The Allure of the Unknown. There's a certain allure to the unknown, a human desire to explore the uncharted territories of our world and beyond. Aoede, with its many mysteries, beckons us to delve deeper, to unravel its secrets and piece together its place in the grand cosmic narrative. We've gleaned some insights from Earth-based observations and theoretical models, but so much about Aoede remains shrouded in shadow. What is the precise composition of its surface? Are there any hidden features such as variations in terrain or composition that we haven't yet detected? Does Aoede harbor any surprises beneath its ancient, cratered surface? These unanswered questions highlight the limitations of our current understanding and the need for further exploration. While we can marvel at images of Jupiter's swirling clouds and the intricate details of its larger moons, Aoede remains a distant, blurry point of light, its secrets hidden from our view. Imagine a vast library filled with ancient texts, each book containing a wealth of knowledge waiting to be discovered. Aoede and countless other unexplored objects in our solar system are like those books, their pages filled with stories of cosmic events, planetary evolution, and perhaps even clues to the origins of life itself. Section 3. A Call for Exploration. The study of our solar system is a journey of discovery, a continuous quest to push the boundaries of our knowledge and explore the unknown. While missions to the outer solar system often focus on the larger, more alluring targets like Europa or Titan, The smaller, irregular moons like Aoede should not be overlooked. Future missions to the Jovian system, equipped with more advanced telescopes and instruments, could provide invaluable insights into Aoede and its companions. Flybys by spacecraft like NASA's Europa Clipper, while primarily focused on Jupiter's icy moon, could capture higher-resolution images of Aoede, revealing surface details and potentially even detecting the presence of specific minerals or compounds. Ultimately, a dedicated mission to the outer Jovian moons, while challenging and expensive, would be the most effective way to unlock the secrets of these distant worlds. Such a mission could involve an orbiter or even a lander, allowing for long-term observations and potentially even sample return. The data gathered from such a mission would be invaluable for understanding the formation, evolution, and potential habitability of these enigmatic objects. As we continue to explore our solar system and beyond, let us remember the importance of looking beyond the obvious, beyond the familiar. For it is often in the most unexpected places, in the shadows of giants, that we find the most profound discoveries, the ones that challenge our assumptions and expand our understanding of the universe we call home.